Alrighty. So we're trying to go through and find some places where we can add some final touches on just the type implementation of essential simple algebra. Just making some comments that way in a pull request. We have something to list as goals. So, this is me. So some stuff. It's actually my first pull request ever. Can't I go to like a profile or something? I don't know why I want to see this. Kind of not important, but I could do it here. Actually, I guess that's it. I wanted to see one more thing. So if you go to for this Hecke project, insights, and you eventually look at contributors. I'm gonna be on here. But how far down am I? Oh, wait. I should be somewhere in there, right? What? Let's do last month. There's me. Oh, it's ordered by commits. So this is just the period of last month. Community standards. God, how many commits have there been all time? How is this ordered? All right. I'm no longer interested. Okay, so we want to make a pull request. And in order to do that, we want to go through and look at the final things that need to be mentioned. Okay, so this is back, which is good. There's stuff in here, probably, that should get moved over. Was one thing that I noticed. I think that things that don't rely on the essential symbol algebra type and are kind of type specific to other types should be moved. So, for example, there's some around here, right? So there's like function standard involution. Should the standard involution actually be defined on a structure constant algebra? No, right? It should be defined on a quaternion algebra. But if I remove that, it's one of those things where and so let's just check what the standard involution does. The one thing that makes me confused is this. So it calls eventually the standard involution function for, so function standard involution, return blank blank standard involution, and then in here function blank blank standard involution. Okay, eventually it calls triple standard involution. But why not just have, I guess, this function in here? That one's not so clear to me. There's no reason to have this function separated now, I imagine. Changing that, though, is going to change a bunch of the calls and errors, I think. Well, I wonder what happens if you... Okay, so let's open up the terminal. Also just check that I didn't... Okay, so... let's try to get this fixed out. Alright, go to Julia. What we want to do using Hecke is check some of these things. So what happens if I call now standard involution on a quaternion algebra? That should return something that makes sense. But because the type is supposed to be a structure constant algebra, I think it should actually error now. That's pretty simple though, we just rewrite. If it doesn't error, I'll be even more confused. So that would be like when we call something a structure constant algebra on quaternion algebra, we actually get a conversion at some point. Right, that was my bad. So let's do Q is quaternion algebra. Easiest one is this one. And we'll do standard involution. I guess it's not in the namespace, so let's do this. That actually gave us something that made sense, so that's weird, ain't it? So this is a file I haven't looked into at all to some extent. Is it even around here somewhere? I don't know where. Oh, should be map, right? Map type. Let's see. Okay, map maybe is not going to be. So here's what we should do. We should search by grep, and we should look up let's see, structure constant algebra. There actually is some function like this, but that's in test. So let's try abs alg s more. So the morphism type is just defined in what file am I in? Just in the, okay. It's just in the, it's just in this original file. So then what we're calling is technically these are all pretty abstract. There's no like this makes sense. All right, that's fine. Because of that, that's a bit weird. It's a bit weird because of this type of assertion. I'm weirded out by that. So there's actually one that functions for just quaternion algebras. Shows up in the same code, but 50 earlier. So 215. So it just checks if it's defined, then you do this. Otherwise you call standard involution like that. Okay, so this actually doesn't make any sense. Okay, the part that we do need. So this is something that actually doesn't make any sense. So it's not needed. I'm just gonna call that that's not needed. And now standard shows up a bunch of times. I think that we could do something like this. And switch that with standard involution. What happens if we call is split with 0 divisor on Q? Should give us false and 0, I guess. And what happens if we do this and call the same thing? We get a method error because the function, the field is not. The field is not an allowable field. That makes sense. There actually should be an algorithm for this, so that's something to think about, I guess. A is Q. And let's do conjugate on A. Let's do reduce trace on A. Reduce characteristic poly on A. Sounds right. Function, standard involution. Let's go ahead and copy this. And just move it up. There's no reason for it to be so far down, I think. I didn't check what happens when you do type of conjugate. stays the same, so this doc has to be updated. I can do that. This is something that I don't necessarily get. Reduce standard form for elements from absolute simple number field and absolute simple number field. Doesn't actually have anything to do with quaternion algebras. This though is something that we could try. I don't think this is gonna actually. No, we can't try. So I don't know how to call. I don't actually know what these types are. I don't know how to call these things. I don't understand why this is down here again. Okay, we should get this standard evolution up. So take that to, I forgot where it was, like here. So now isomorphism. Let's try with yeah, there's two inputs. Type quaternion algebra. Not sure what this function does at the moment. This is really only ever called here. So I guess that's why. So I just wanted to point that one out. Comments are fine. Oh. So with the changes, actually, we can't get... Ah, because you want to call it on a... Oh, you want to call it on... I see. You want to call it on a structure constant algebra so that you can check if it is. Yeah, that makes sense. It just shouldn't be repeated then, right? I guess is the... So here the type... These functions, actually, it's important not to have the type. So if we do is quaternion algebra, then F calling the standard involution. That'll no longer work, I think. It will work if you just change it, but then it's not cached. Probably shouldn't be cached though, right? Yeah. So we're just gonna go back to is quaternion algebra. And I think that this should be just underline it. I'm gonna write it, fuck it. We're gonna exit Julia and then launch again. Reload Hecke. And then we're gonna try some of these out. Okay, so let's call this quaternion algebra back. And let's do standard involution. Q, we'll call that F. We'll define some element. We'll do F of A. Great. And now we do, so is quaternion algebra? I don't remember what the function was. Is quaternion algebra. Q. Error. Great. Oh, actually not great. That's great though. So A, G, call structure constant algebra on this. And now we'll do the same thing, but we'll call this on A. It's true. So we get a map. If I actually specified it. From a quaternion algebra to a structure constant algebra. And if I conjugate A, it's great. If I do reduce trace on A, this is great also. So type. So you can just call this is weird though. You can do like QA. No, it's you have to call like quaternion algebra A or something. Bit strange. So conjugation's totally fine. Isomorphism, I think at this point should be separated out. So let's go up to isomorphism. And down. Delete that. We're going to go to where it has a conversion. And we're going to paste this here. Write that also. I don't like any of this. Do they have a have simple number field or some shit like that as a type? Look in here maybe. So let's try doing a little grep again for have simple num field. And I think this is going to be abstract type. I don't remember the call for this though. Is that a Nemo type? Let's go Gemini. Damn. Okay. So it's a Nemo type. I wonder if I can group this with kind of another browser that I've got on the side. I'll just close out of it. Okay. Great. We should be able to do something like this. Ooh. You just multiply. That can't be true. Okay, let's try running the docs and then generating the docs. I think this is like the last thing that I need to do. And then I should probably just like start a draft pull request so that it's at least around. So we can apparently do Hecke.build doc, fix doc tests. I actually want to clear this and then do it again. I don't know if that's going to be problematic. Yeah, that's what I thought. Let's just quit it. Let's reload. Precompile. Do this. Okay. I can check some tests in the meantime. See if there's anything that would have actually used this. No, just these. This one's kind of interesting. So there is something that shows up in aljaz abs order. Abs as alg order. Abs as alg order. Abs alg as order. Alg as abs. Okay, there was one that showed up in pip. for example. Okay. Ah. So source alg as abs order. It was alg as abs order. And then in pip. We just go here. Calling standard involution on B. Just have to check if B is supposed to be a quaternion algebra then, or what? No, it wasn't, I imagine. There's certainly no harm in doing that, I think. Let's check just to compare. Okay, I could actually see that changing some things. Yeah, let's change this back. And just write it just in case, and then let's just quit. Cancel that. I feel like this can't be the right. Just going to check the source just to see that there's really a macro for est set. Because I fucked something up earlier typing in there. I think this is maximal. It's test. Yeah, that's supposed to be test. Right. Quit. So I'm in test also. Should have known that. Yeah. This one I really there's no reason why this had to have changes. Yeah. My bad. What did I even change? Hey, Cha-Cha. Whoa. Oh, bud. If you're here, it's gonna take so much longer to go to get this done. If you're here, it's gonna take so much longer to get this done. You just want to walk over there? I doubt it. You want to sit on my lap? Okay. I think to some extent that's it for tonight. Just I'm just probably gonna end it. I should probably just end it. I'll probably just end it. And then come back tomorrow. Okay, fuck it. Okay. I think I'm gonna go to bed. Let this run in the background and check on it in the morning. Alright. Peace.